Hi, my name is Kartik Bhatia, and today I'm going to be taking a workshop on an introduction to web APIs. This is for Hot 11, which is taking place on Sunday, March 1st in the Palisade Rooms. So let's get started. So the first thing is here's a permalink to the sites, so you can come back slides anytime you want. Um, and yeah, the agenda for today, we're going to be covering the client server model, which is essential to understanding how CS works. Then we'll understand how APIs themselves work. And then an overview of HTTP, which is sort of the foundation of APIs. Then a little primer on JSON, keeping your API keys safe, and then a quick demo. So let's dive right in. So clients, servers. This picture is a pretty intuitive understanding of what's happening. In this picture, the client and server are both computers. And the client requests the server for information or to do some sort of task. And of course, when you send a request, you have to get back a response, which is what the server sends back after fulfilling the request. Um, so let's use a quick analogy over here. So let's use the analogy of an ATM. Here you are the client and the bank is the server. Now you enter your card and PIN into the ATM. The bank receives a request and you receive your money or deposit it, depending on what you want to do. Many clients can make requests to the same server. So you see multiple people using multiple ATMs across the world for the same bank. Same way over here for clients and servers. And yeah, the server hides the complexities from its clients. So you don't really know what's going on in the backend once you use an ATM. It's all hidden in a process called abstraction. So how do APIs fit into this whole analogy? Well, the ATM is the API. It's sort of a middleman between you and the bank, or the clients and the server. So the ATM takes your info, it tells the bank how to change your bank balance, and then gives money back to the customers, or takes their money, depending on what you want to do. So yeah, that's how APIs in general work. APIs stands for Application Programming Interface, and it's a really general term used for how different software components interact with one another. Um, for our case, it's the communication between clients and a server, but there are different sort of things. You can research that in your own time. Um, and yeah, the specific thing that we're going to be talking about today are web APIs, which is a communication channel over the internet. And it uses something called HTTP, which we'll talk about in just a second. So web APIs are nothing special, literally just APIs used over the web. An example might be a Google Web API. So, for example, those pesky ads that you see on many websites, most of them are brought to you through APIs, where Google is the server and the app itself is the client, and the ads are gotten through an API call. So yeah, let's talk about HTTP. What does it stand for? It stands for Hypertext Transfer Protocol. But what it really just is a bunch of rules that web APIs follow. It kind of defines how requests are made and how responses are given. It's just a way to standardize everything so that all APIs have a similar structure to them. Um, in our analogy, it's equivalent to the way you ask an ATM for money. There are certain sequence of buttons that you have to click. And yeah, that's what HTTP is. You've probably heard of HTTPS before. That's probably the prefix to most of the links we use on the web. It's the exact same thing as HTTP, but more secure. Quite creatively, that's what the S stands for, secure. But yeah, so we talked about requests and responses. Let's see how these work when you're doing it through the hypertext transfer protocol. This is an example of a request that you might make. I know it looks a little um, confusing, but we'll break it down really nicely. So the first word you might notice is post. This is called an HTTP method. Now, the above are four methods that are most common when you're making HTTP requests. They're all pretty intuitive by their name, except maybe put, which is updating an existing file or resource in the server. Now, these are all based off something called CRUD operations, which are create, read, update, and delete. These are again the four main things that you're gonna want to do. So yeah, that's the first thing that you you send in your request, it's kind of telling the server, hey, this is what I want to do with the data that I'm now going to give you. The URL, this is where the request should go. So it's just an address. For example, when you're sending a mail to someone, you need to know where to send that mail to, right? Even in an ATM, the ATM needs to know which bank to request and where to send that request, right? So that is just what this URL is. Next, HTTP. So we recognize this. This is telling us what protocol we've used. It's either HTTP or if you're a little more secure, HTTPS. 1.1 is just a version number over here. The different versions have different advantages, disadvantages, but 1.1 is like the most common and easiest. Then you might have some headers. These are just optional extra details. For example, over here, content type, it's just saying, I'm going to send you some data. Here's the format in which I'm sending you that data. You might have a bunch of other headers, but these aren't essential to the API call. The last is the body. So this is the data that you might want to send along with your request. We'll see an example of this later as well. Now that we know how the requests work, let's talk about when the server replies to you or sends its response back. So you'll see that the format is somewhat similar to um, our requests, wherein we see the head has HTTP, which is again the protocol. Now, something new here is the status code. Over here, a status code is literally, well, it tells you whether your request was denied or accepted or was successful, basically. Over here, the 200 OK means that everything was successful and the server managed to complete your request. Again, it might have some headers like the content type, but again, this is meta info and it's not really important. Um, the most important part, arguably, is the body of your response. This is, well, you might request some data, and this is the response that you're getting. This is the data that you really want. And over here, for example, it's a snippet of HTML code. It can be literally anything. Um, so yeah, a little bit more on the status codes. Um, that they have a certain structure to them in the sense that anything starting with a one is like purely informational. Anything starting with a two tells you, okay, everything went well, it was successful. Three means that there's redirection. Maybe a certain URL redirects to another website, so you might get a status code for that. Anything starting with a four is a client error, which means something that went wrong on your side. You made an incorrect request, maybe. Whereas anything starting with a five is a problem with the server, where due to their own error, they weren't able to complete your request. Some really common status codes we saw earlier was 200 OK, which means everything went great. This is, if we see this, we're really happy. Um, then yeah, 404. This is the one that we've most commonly seen on the internet. You've probably seen a lot of memes as well. It just means that the page was not found. So maybe you requested an incorrect URL. Or 403 forbidden. This might happen if you're trying to gain access to a site in which you don't have access, like if you haven't logged in yet, maybe. Um, and yeah, 500, which is just an internal server error. Again, nothing went wrong on your side. It was on the server side. This might result in you having to wait a bit until they fix their problems. But yeah, these are response status codes. Moving on. So when we talked about when we earlier we saw that there's a specific format in which you sent your data. We saw application slash JSON. Let's talk about what JSON is. It stands for JavaScript Object Notation. And what it really is just a simple format. It's like the go-to format used in the body section of requests and responses. So again, this is another way to standardize how APIs send you your data and how you send your data to them. Um, if any of you guys have done Python, you might recognize or find it familiar that these have name value pairs, sort of like a dictionary. And they use arrays and other sort of data structures as well. So we see this is just a really neat way to represent your data. Um, so the data over here might be a response to, say, an API which gives you information about a person or a character in a video game, for example. So you might have sent the data that I want information about a guy named John Smith. And this is the data that you've been sent back. So you can see very clearly that they've said their first name is John, last name is Smith, and they've given you a bunch of other information as well. So yeah, Let's talk about keeping your API keys safe. This is arguably the most important part about APIs in general. Most APIs want you to have a key, which is sort of a unique way of saying, yes, I'm allowed to access this API, and here's my code. It's like how you get in, it's like your PIN for the ATM. And obviously, it's very risky if someone else gets yours because they can make requests on your behalf. Now, when you're paying for an API per request that you make, this can be really dangerous as someone can just rack up a bill for you. And that's why we say you never hard code your key in the source code. Always store it in a .env file, which is an environment variable file, and add it to git ignore. A git ignore is basically something that says when you're pushing this to GitHub, just ignore these files. Um, you can learn more about it in our workshop about Git, which you can find on our website. But yeah, don't worry too much if you do it by mistake. We've all done it before. If you do, the easiest thing to do is just generate a new API key and stop using the old one. So sort of disable it if you can. Um, and yeah, I think that's pretty much it. Let's jump into a quick demo now. What we're going to be doing is making a simple movie search tool using the OMDB API, which is Open Movies Database. A prereq here is a basic understanding of React, which is just a framework for building on the web. We'll be using Vite as well, which is like a front-end build tool, which allows us to host our website locally. Don't worry too much if you don't really know React or Vite. We have a bunch of workshops about all of this, and you can find at this link over here on our website mainly. We do run a stack school as well that helps you with full stack development. So be sure to check that out. So yeah, some quick project setup. Um, so first you might want to create a folder for this specific demo and then open that folder in terminal using the cd command and then run these three commands. Now, excuse me, sorry. These you'll learn about in our React workshop as well, but this basically just creates a quick template in React, a really simple one using Vite, and then it moves into that folder and it installs all the required dependencies and runs it as well. Um, then next, you're going to want to open that folder in VS Code and just remove the initial, like you get a template, right? So you'll want to remove like the code in those specific files, which is app.jsx. And the styling in app.css and just completely remove index.css. So we don't need it for this project. Um, so I've already done that basic setup. I'll show you in a second. The next thing is to get an API key. You can get it over here at this link. If we just quickly follow that. Yeah. So make sure you get the free one unless you're willing to pay on Patreon. Enter an email and just get an API key. With that, you're gonna get an email and oops, the Wi-Fi seems to be a little slow. Sorry, guys. Um, okay, so in the meanwhile, you'll just get an email with it with all the information, and you just have to click a link to confirm to activate your code and make sure you copy down that code. That's really important. So once you do get that code, what you're going to want to do, I have no clue why this isn't loading. I don't know. The internet seems to be a little slow today. Right. Sorry for that interruption. So yeah, you'll go on the website, you'll see a page like this, just fill it in with some information, click submit, and you'll get an email. You have to activate your key by clicking the link on that email and note down your secret API key. It's just going to be a bunch of random characters. And what we want to do is in your root directory, not in the src folder, you in the very root of it, you want to create a file just named .env. I know that might be a little weird that it just has an extension, but that's just the name of the file. And store your key as an environment variable. So we see in this photo, it's that you just any name you want really is equal to and then your API code. Here I've just done Vite underscore API key. Um, so yeah. Next, you want to kind of create the app. So this is just some basic React where we initialize some states. We have a query state and a movie state. The query is, of course, the movie that we're going to search for. And the movie itself represents like the information that we're going to want to display afterwards. Um, so yeah, just moving to Visual Studio really quickly. I already have this set up over here. I'll show you my env. Don't try and use this API key. I'm going to disable it after this. But yeah, it's going to look something like that. Just store it like this, and that's completely fine. Going to app.jsx, we have some basic React imports. We create our two states. Um, and yeah, let's talk about the front end really quickly. This is just some basic HTML. What we really want to talk about is the input. So now when you do input, you want the value of the input to be the query in our React state so that we can use that query variable later. And when we change our input, we want to change that query value to the value of our input as well. So this is what that on change function is doing. This placeholder is just some text that will show inside your um, the search bar. The next thing is a button so that we can actually click search. And now on click, we're going to have a search movie function, which is going to do our actual API call. For now, I've just left it blank. We will come back to this, but you can just leave it blank for now as well. The next part is, yeah, the actual front end, the info that will be showing about our movie. Now, this little piece of syntax is kind of interesting. It's sort of saying if there is if movie has some sort of value at all, then only you should display the following UI. Um, and if it doesn't exist, then just ignore this UI. Okay, once our movie does exist, we want to show its title, its year, the plot, the poster. And if the poster we can't find, then we just want to show the title instead. So, really quickly, how do we know that these fields exist? We can find all of this when we go to that website for the API, which is over here. If you open the documentation for it, for example, you will see that they have like a quick search thing. So maybe I search for a movie and it shows me all the sort of data that I can get. So we get the title, the year, rated, release. There's a bunch of information, and you can go through all of this in your own time. This is potential fields that you could use in your app, but we're just going to use the title, the plot, the year, and the poster. So yeah, really simple front end. Um, and yeah, so coming back, we want to start on the actual API call. So before that, I want to briefly talk about asynchronous programming. Um, so basically, when you have some functions that take a really long time to run, but you don't want to stop the rest of your application in the meantime, use something called an asynchronous function, which, as the name makes it sound, it says, well, hey, I've started this process, but you just continue with the rest of it in the meanwhile. And now, say you come to another part that requires the output from that initial function, you can use the keyword await to say, wait, let that function finish and then only run this code. So we use the keyword async to make a function asynchronous, and we use await to wait for its output, right? So our API calls will be asynchronous as it does take time to make an API call over the web. But obviously, we don't want to display any information before we get it. And so the actual setting of the movie data and like fetching the response, we want to wait for it to come, right? So yeah, let's start building out our function. It's obviously asynchronous. Now, the first thing we want to do is have a URL. We saw in our response format that we do need a URL to go to. Again, we can find this in the documentation. Um, So when you go over here, it says send all your requests to OMDB, blah, blah, blah. And then your API key comes over here. And then there's an and then any parameter that you want. Now, looking at the parameters, we want the movie title to search for, which is the parameter T. Again, when we go through the example, we can see that the call was using the parameter T over here. So um, let's make this as a variable really quickly, const URL is equal to, and luckily we are getting some sort of help, but maybe we don't want to use that right now because it is overcomplicating it. So yeah, we're going to do question t is equal to, and then over here, what we really want in this is our query, right? So we can just use query as a variable over here, and then and API key. Now, this is where it comes in. How do you import your environmental variable? You literally just do, well, as it shows, import dot meta dot env, and then your the name of your variable. Um, so yeah, that's how we figure out what URL we want to go to. Now, the next thing is, as the code already shows, it's sort of try and catch. So we try something out, and if it doesn't work, we're going to try and catch the error that it outputs. And if with that error, we're going to try and console log it through console.error. Uh, but yeah, if we do get it, we want to do a bunch of stuff, right? So the first thing we want to do is fetch the response. So that's what the function fetch does. It uses our URL and it just fetches that information for us. Now we want to wait for this to finish since we're already in an asynchronous function. Now once we do fetch the response, we want to make sure that it's formatted in a way we understand, and that's why we do response.json. Again, we wait for this to finish before we do anything else. Now, if our response is positive, that means that the response has been completed or it's true. Then we want to set movie, which is displaying this little UI over here. Otherwise, we want to catch any error that we get and output it to our console. So with that, that should pretty much finish our app. And yeah, remember when you do run those commands on terminal, it will give you a little URL on which you can search. So yeah, if I were to search a movie like It, you can see that it displays all the required information now. You can do this with any movie and it should work. So again, with Inception. Um, and yeah, that's our demo pretty much complete. Um, so yeah, some common APIs that you might be using in this hackathon or any other is a weather API, which is called Open Weather Map. This is completely free and it gives you the current weather and forecasts, which might be really helpful if you're making, for example, a weather app. A news API to get like recent headlines. You might want to do something fun with this, maybe some sort of sentiment analysis. Um, then, of course, we have the Google Maps platform. This might be paid, so you might want to check, but it gives you access to their map, their location search, directions. There's a free alternative called Mapbox as well, but I guess it has features missing. So yeah, there's a few others, namely Twilio, which allows you to send SMSs and make calls through your app. The cat API, which gives you random cat images and facts, of course, very important. And Gemini API. So in this new age, you might want to add some AI to your app. And yeah, Gemini can help out with that. There are a bunch of others, so go ahead, look around, see what you can find. So yeah, thank you and good luck. Have a great hackathon and a great rest of your week. Cheers.